Well, hello. Today we are going to be discussing simple interest. Now, w- this idea of simple interest, that just means paying some extra money whenever you borrow money. Whenever you use someone else's money, you got to give them all of their money back and some extra money. That's really what interest is. It's extra money on top of the money that you owe. So, with that, let's go ahead and get started. So we're just going to calculate simple interest. Now, most banks operate with compound interest, but we need to understand the idea of simple interest before we can make it compound. Now, compound doesn't actually mean that it's harder. It just means that you're going to be getting more of it. Okay? So um, interest has a formula, and it's this formula right down here. It's called I equals PRT. So I stands for the interest that you have. That's the money that you borrow. P is the principal. Principal means like the amount of money that you're borrowing. Okay, if you take out $1,000 from the bank, then your principal is $1,000. That's the first amount of money that you're starting with. The rate, we always want to, we express as a percent, but we use it as a decimal. Okay, and then the number of days, months or years. However, the interest is expressed, so like if our interest rate is expressed as an annual rate, which is most common, then your time must also be in years. If the interest rate is expressed as a monthly rate, then your time has to be in months. Or, if your time is expressed in months and your rate is expressed in years, then you could change the rate to match the time. Whatever it is, these two have to match as far as their label goes. And then we just have this very simple, straightforward formula. I equals PRT. Okay, let's go ahead and take a look at a very straightforward one. Chad's going to borrow $2,200 to have some corrective eye surgery. He obtains an 18-month loan with an annual simple interest. So annual means yearly. And notice here it says 18-month loan. So that means that we are not operating in the same label. Annual means years, and this is in months. So let's go ahead and take a look at what we've got here. We need to figure out the interest, and that's what we don't know. So I'm just going to leave that as I for now. We know that we're going to be using this formula, I equals PRT. So if we don't know the interest, that means we have to know the other three things. That's how algebra works. Like you solve for the thing you don't know, and if we have two of them that we don't know, we can't really solve for it very well. You could isolate and solve for the variable. You can't really get a number. So P, the principal, that's the amount of money we're borrowing. That's $2,200. Okay. Then after that, the rate, well, the rate they tell us is 7.5%. And what we're going to do is change that into a decimal by moving the decimal over two places. That's what we talked about in a previous lesson. So this would be 0.075. 7.5% will turn into 0.075. And then our time, they tell us, is 18 months. But here's the thing. Remember this is years. This is in years. Therefore, we need this to also be in years. We're going to convert that into years. 18 months, is a little over a year, right? It's actually a year and a half. And the way that we do that is very easy. We just take 18 months and we would divide it by 12 months in a year. This becomes, our months and months would cancel out. We just have our label left of years. And this becomes then 1.5 years. So now we have everything that we need. We have our P, we have our R, and we have our T. And then we just plug those into this equation, this I equals PRT. So we'll put those in, and we get I equals 2,200 times 0.075 times 1.5. And then we're done. Well, sorry. you would use your calculator probably, and you get 247.50, and that of course is dollars. Now we're done. Okay, so the amount of interest, if you borrow $2,200, a year and a half later, you have to pay back the money along with the interest. So the first part of this problem says, how much is the interest that he's going to pay? It's that. The second part says, determine how much Chad's going to pay back. Well, when he goes to pay back, he has to pay back not only the interest, but of course he has to give back the part he took, the $2,200. They're going to say, hey, do you have our $2,200? He's going to say yes. And you say, by the way, you owe us some interest. You owe us some money for borrowing that money. And so the total that he'll pay back then is going to be $24.47.50. So even though he borrowed $2,200, he has to pay back more than the $2,200. So 18 months later, this is what he needs to walk into the credit union with. Philip, what a great name, agrees to lend $850 to his friend Joe to travel to Cincinnati to attend a family wedding. 9 months later, Joe repaid the original $850 plus $51 in interest. What annual interest rate did Joe pay Philip? Now, if you now this might seem a little contrived, and you're like, "That's weird," but if you think about this, let's consider this maybe an even more real life scenario. I probably should have changed it, but I wanted to keep it very straightforward so you can identify interest. How about this? Somebody loans you some money, you pay them back, and you get them a gift card. You know, like you say, "Hey, I really appreciate you helped me out of a tight spot. Here's a $50 gift card to Applebee's," you know, or whatever. Like, that's something that happens. You borrow some money and you pay back and you get him a little gift. Now, Phil didn't charge him any interest, but Joe decided to do something nice and he gave him some extra money. So in a sense, that gift counts as interest, right? So what we're going to do is we're going to do this I equals PRT. Now, I had the problem worded that way so that you could kind of get this figured out. The amount of interest, that's like that gift card that he gave him, right? So he actually gave him $51 in interest. The principal, he borrowed $850, and the time was 9 months. Now, traditionally, interest is usually calculated annually, so that means we should probably turn this into 9/12, which is 0.75 years. The rate, that's what we don't know. So we'll leave that as R. Remember, we're going to do I equals PRT. And then we're going to say that's $51 equals P, that's 850, times R, that's what I don't know, times T, which is 0.75. Now, you could do this a couple ways. You could divide both sides by 850, then divide both sides by 0.75. I actually would prefer to multiply the 850 and the 0.75 together. So if we do that, we get 51 equals 637.5 R, and then we'll divide both sides by 637. The 637 came because I just multiplied together this one and this one. I multiplied those two numbers together. Okay, so now we're going to divide both sides by 637.5, and that gets me R equals 0.08. Remember, we need to change this from a decimal back to a percent. An annual interest rate is always expressed as a percent. So we need to change this by moving the decimal over 2 places. This is 8%. So you could think of this as you know, if who was it, Joe gives Phil a $50 gift card, you know, maybe Phil didn't ask for that, but in a sense, Joe paid an 8% interest rate for that money. Pawn shops. Pawn shops are kind of going out of fashion a little bit, but they're still around. We can, but anyways, pawn shops. So Gilbert decided to pawn his trumpet. So what he's going to do is go into I don't know why I can't move that. All right, well, he's going to go into a pawn shop and he's going to say, here's my trumpet. And the pawn shop owner is going to give him $240. Then 30 days later, he's going to come back and the pawn shop said, hey, we'll hold this trumpet for 30 days. We will not sell it. Here's a claim ticket. You can come back and you can buy this anytime in the next 30 days. After that, all bets are off. We're going to sell it for what we want to sell it for. But if you want to come back, then you've got to pay $288 to get your trumpet back. Now, they won't call that interest. What they'll call it is some kind of a processing fee. They'll say maybe something like, hey, we'll give you $240. You can buy it back for $240 as well. Just pay a fee. Just pay the processing fee of $48. You hear that wording a lot, processing fee. So anyways, what's the annual interest rate? If we count that processing fee, if we think about that in terms of interest, meaning like money that you're paying to use someone else's money, then let's figure out what that's going to look like. So he's going to borrow 240 and he's going to pay back 288. So how much extra money did he pay back? The extra money is going to be what he paid back minus what he borrowed. You see, he ended up paying $48 extra. This is the interest. Okay, so let's go ahead and get this figured out here. Our interest is $48. The principal, that's how much money he borrowed. He borrowed $240. The rate, well, that's what we don't know. And the time was 30 days. Now, here's what we're going to do. We're going to say 30 days. We're just going to call that 1 month. Now, and we could do 30 over 365. It's going to get you an answer real close, and I wouldn't count it wrong. But we're going to call that 1 month, which is 1/12 of a year. Okay? So now that we have that, we're just going to plug everything into this I equals PRT equation. I, that's $48, equals P, that's 240, times R, times 1/12. Now, just like before, what we're going to do is we'll probably go ahead and multiply together the 240 and the 1/12. Let's do that first. Now, here's the other thing is never round in these problems. Okay? Here's let's go ahead and look at this on a calculator. Here's a mistake that I see people make all the time. They'll say, well, let's do 1 divided by 12, and they get 0.083. Then they come back here and they write 0.083. But that is not correct. Is this right here 0.083? No, it's 0.083 forever. So do not round in the middle of a problem when we're talking about money. There's a great movie called Office Space, and it all talks about taking fractions of a penny and fractions of a cent and putting them all together. They really add up. And so these fractions of a percent, they do add up. You can't just ignore it. So we're going to leave that in there. In fact, what I would do is I would take that, and now I would take that times 240. That gets me, in this case, a pretty nice number, just 20. So when I take 240 times 1/12, I get 20R equals 48. Now we'll divide both sides by 20. And then when you do that, you end up getting R equal to 2.4. Now, the interest rate is not 2.4%. That would be wrong. Please don't do that. No, remember, we have to write this as a percent. We've got to convert this. So we would take this 2.4 and we move that decimal 2 places. This is a 240% interest rate. That is insane. But it all comes back. They don't call it an interest rate. That's why they don't call it interest. They'll just call it a processing fee. They'll say, "Sure, we'll loan you the money. Just pay this little fee here, and then you're good." Okay, so a 240% interest rate is what they're charging this person. Okay, Gilbert. That's right. All right, so please be careful with your calculator. That's what I mean. Don't round. Okay, a couple other things. We're going to talk about what's called a discount note and a bank discount. A discount note is whenever you pay the interest right up front. In fact, if you go to borrow $1,000, they don't actually give you $1,000. They'll say, "Oh, there's a little processing fee, or or you got to pay the interest right now, and so instead of $1,000, we're just going to give you like $930, but you still have to pay back 1,000." Okay, so this is called a discount note. It is a lot more common than what I thought. I had students come in and show me bank statements before and show me loan details, and they'd be like, "I don't understand. I got a loan for $3,000, but they only put $2,912 in my account. What happened? Do I need to?" And we're like, "Well, that's called a discount note." Okay. All right. So let's say Sally took out a $500 loan using a 10% discount note for a period of 3 months. Let's go ahead and determine the interest that she paid back the date she received the loan. Okay, so it's the interest that she pays right away. Okay, well, we are trying to find interest, and so we'll leave that as I. The principal, she borrowed $500, and her rate is just 10%. And so we'll change that into just 0.10, or just 0.1. And then our time is 3 months. Remember, we need to change this into years, and we would do that by saying 3 over 12 months, or I should say 3 over 12 years. And so that's just 1/4, or 0.25. And that is exactly 0.25, and so I can write it as 0.25. Okay. If we had 4/12 and 1/3, you would not see me write this as 0.33 or 0.33. I would leave it as 1/3. Okay, now we have interest equals PRT, I equals PRT, 500 times 0.10 times 0.25. So our interest ends up being $12.50. Now, that's the amount of interest she pays on the date she receives the loan. You can think about it two different ways. They could say, "Hey, pay us $12.50 right now," and she gives them $12.50, and they say, "Okay, cool. Here's your $500 that you wanted." And then she walks out of the bank with 5 $100 bills, and she just had to give them $12.50. The other way to think about it is that they might say, "Okay, you wanted a $500 loan. You got to pay the interest right now. It's $12.50. So we're just going to deduct that from what you're getting." And so the amount of money she receives from the bank is the 500 that she wants to borrow minus the interest, the $12.50. So really, she walks out of the bank with $487.50 if she got this on a discount note. The loan has been discounted by the interest amount. The loan has been discounted by $12.50 right up front. Okay. Now, if we wanted to compare that to an actual interest rate on a standard loan, then here's the way you think about it. She did not actually walk out of the bank with $500. Okay. Now, the loan was for $500. Let's be clear about this. It is a discount loan for $500. But let's compare apples to apples. Let's compare this with a loan that is not considered a discount note, just a regular simple interest loan. That's what we want to compare it with, because that's what most people understand. Well, in this case, she didn't actually walk out of the bank with $500. She actually walked out of the bank with $487.50. And so let's go through and figure this up here. 487.50, if we count that as her principal and the 1250 is her interest, let's figure out what annual simple interest rate they would be charging her. The time, of course, is still 3 months, which is 0.25. So if we plug all these into I equals P R T, I would get 1250 equals P, that's 487.50, times R times 0.25. Okay, and we go through and we would multiply this out. Let's go ahead and do that actually. So let's take our 487.5. You could do 0.50. I'm not going to. Times 0.25, or you could do times 1/4. So this is what the right side of our equation is, and I'm going to use this whole number, 121.875. I know you can't have half a cent, that the bank's not going to give that to you. It doesn't matter. We want to solve for R, so we're going to leave this here. Now you divide both sides by 121.875. And I'm going to show you kind of a trick. Most calculators have a little button down here that looks like this. It says answer. So we're going to use that here in a second. I need to take $12.50 divided by 121. And so I can do this. I could say $12.50 divided by, and I could just type it in. This is not that big of a number. I could type in 121.875. But I can also just do second answer. And this is a nice button to use, especially whenever you have maybe something like this, where you have a long decimal and you want to use that whole big long decimal. So you just hit, in this calculator, it's shift answer. If you have a TI calculator, it would be like second answer is down here. A lot of the calculators have a little answer button. You just got to look for it. Now what I get is 0.102564, etc. So this, now we do have to round because we actually have to record our answer. Maybe something like that. And if you just chopped it off, it'd be 0.1025 or round it. I don't really care. That's not the point here. But if we change this to a percent, this would be 10.25%. Now here's what's kind of weird, and it's a little bit tricky to understand. I would encourage you to, if this is something you really want to know more about and whether or not you're being taken advantage of or what's happening, you can definitely learn more about discount notes. Just Google search it. Okay, we just did one problem together here, but the advantage to the bank is advertising a 10% interest rate on a discount note. Okay, and you hear 10% interest rate and you're like, oh, that's not so bad. I mean, it is pretty high, but the thing is they can advertise this lower rate because of how the loan works. They're not technically lying to you. Okay, maybe if Bank A has a standard loan at 10.1% and Bank B, this bank, has a discount loan at 10%, you might think that bank, let's see, A 10.1% and B 10%, you would say, oh, Bank B is a better deal. It's a better deal. It's a lower interest rate, and I know, my math teacher told me lower interest rates are equal better for me. And you might just jump in here and say, yep, that's what I want. But if Bank B is a discount note and Bank A is just a standard loan, then in actuality, if we want to compare apples to apples, we just did that. We figured out a 10% loan for that period of time actually comes out to be 10.25%. And so in that case, Bank A is the better deal. So it's really kind of a way for banks to kind of advertise lower interest rates. Okay. All right, let's go ahead and look now at a nice little problem called partial payments. This was a big deal before. It's not as common now. It seems like everyone has credit cards, and a lot of people don't do these types of partial payment problems so much anymore. Whoops, jumping ahead of myself here. All right. Okay. So what's going to happen here is Ken's going to go in to buy a new racing bike. The bike costs $2,000, but he doesn't have $2,000 and he doesn't have a credit card apparently. And he probably shouldn't put it on his credit card anyways. He can't afford it. So the bike shop owner has two different payment options. He could pay $1,000 now and then come back and pay $1,150 in 6 months, or he could pay $500 right now and then $1,700 in 6 months. Which payment has a higher annual simple interest rate? Well, if we just look at this, we could say like total, he's paying $2,150 for the bike, $2,150, and here his total is $2,200. And so we would say he's paying more money with the second option. That is clear. That's very apparent, hopefully. You just add the two up, and he's paying $2,200 for a bike that really only costs $2,000. But because he's spreading out his payments, he has to pay interest on this. Okay? But that's not what the question says. It doesn't say which one is he paying more for. It says which payment has a higher interest rate. So that means interest rate, we have to go through and solve I equals PRT. That's what we got to solve. So we're going to go through and figure out I equals PRT for both of these scenarios. The first scenario here, you can kind of see it, I hope. If he ends up paying a total of $2,150 for a bike that costs $2,000, how much is the interest? Remember, interest is the extra money that you're paying. Well, the bike technically only costs $2,000, but when you add up all of his payments, he's paying $2,150. That means that he's paying $150 extra. And what do we call the extra money? We call it interest. So we could say this, 150 is the interest. Okay? The principal, this is actually the tricky part. The principal is how much money you're borrowing. And here's what you need to remember. You want to write this formula down because we're going to use it a lot in this whole chapter. Okay, the principal, why did I just forget if it's the I or the E? I or E. It's the A. Okay, so the principal, that is equal to the cost minus the down payment. Down payment means the amount of money you pay right up front. The principal is equal to the cost minus the down payment. Please make sure you write that down. In this case, our principal is going to be $2,000 is the cost of the bike. How much money does he give the guy right now? He gives him $1,000. And that means that he is going to be borrowing $1,000. The principal is $1,000. The rate, that's what we don't know. And then the time, it's 6 months, and so we would use 6/12 or 1/2. Okay, that's where all those numbers came from for our first option. Now let's go ahead and jump ahead. I have this worked out already and have it typed out so it's in a little bit more orderly fashion. Okay, so our interest, oops, don't jump down. That's not what I want. The total amount you paid minus the original cost, that was the extra money that we had, right? And we can say that this is going to be obnoxious. So now we have the principal. That's the cost of the bike minus the down payment. Okay, maybe I can do this. Forget it. I just got rid of it. So Our time then, of course, was 6 months, a half. We got all this. We found out that R is 0.3, and that's a 30% interest rate. So under option 1, it's a 30% interest rate. Under option 2, if we do a $500 down and we pay off the $1,700, okay, so remember, in total, we're going to be paying $2,200, and the bike costs $2,000. That means that we're paying $200 extra, so that's our interest. Now for the principal, and this is really what people struggle with, but you got to think about this. The bike cost, so our principal is equal to the cost minus the down payment. Down payment means like how much are you giving them right now? So the principal, the cost of the bike is $2,000, and he's giving them $500 right now. That means that our principal, the amount of money we're technically borrowing from the bike shop, is $1,500. Our rate we don't know, of course, and the time is still 6 months. So we have half a year. Okay, so we'll use our I equals PRT. We plug in the numbers. Ooh, that's kind of fun. We take 1,500 times 0.5, we get our 750. Divide both sides. Oops. There we go. And we get 0.266. And that will then become 26.6% interest. Okay. And it would keep going. You probably should round it to maybe 26.7 or 26.67. Like, whatever it may be, you should probably round it appropriately. Just round it to whatever the directions on the problem say. Since we don't really have directions, we're good at this. Okay, a little bit more vocabulary. Partial payment. This is whenever, and this is whenever you're not going to pay the whole loan off all at once. It's kind of like when you buy a car, they call that installment buying, but it's still a partial payment problem. It's whenever you give some of the money back now, and then you give a little bit more later, and then maybe a little bit more after that, and then eventually pay it all off. So it's whenever you're not going to pay the whole loan off all at once. And this is really how the world works for most cases. The U.S. rule. If partial payments are made, then first you pay the interest, then the rest is applied to the principal. Okay, and that's really important. And it actually, we could get into a philosophical debate about this, but I do think it probably really is the right way to do things, especially in a capitalistic society. So it just means that if you owe $1,000 and interest happens, interest accrues, then whenever you go to make your payment, if you have like $30 worth of interest that happens, then you make your payment. It's almost like you owe $1,030, right? Then you subtract your payment off that. Some people would say, like, if you were going to pay $100, then the first 30 is interest, and then the rest, the 70, would go towards the principal. So we'll look at some examples with this stuff later on, but that's called the U.S. rule. And then the banker's rule. It just means that anytime you're going to have a number in the denominator, we use 360. We don't use 365. You can look up the history on this. It's really just because 360 is a nicer number to divide by than 365. Okay. So whenever you're putting a number in bottom, we'll never put 365 down on bottom. We'll only ever use 360 for the banker's rule. Here's a nice little chart. It's got tons of numbers on it. I'm sure you can't even see it, but you can see January, February, March, April, May. It has the numbers 1 through 31 all the way down here. And all this shows you is that what day of the year certain dates happen on. For instance, July 1st is the 182nd day of the year. So you can find a numbers chart like this and get some practice. So for instance, what's the 256th day of the year? Make sure you can look on your chart. If you have printed out a college math reference sheet, then you can use that. But the 256th day is September 13th, right? March 23rd, it's the 82nd day. So that's all. Make sure the ones that are kind of tricky are when you go past the new year. Okay, those are the ones that are a little bit harder. If you take out a loan on December 26th and it's due back in 79 days, when is it due? Make sure you practice that. Go back to your chart and you take it out on December 25th and 26th. And then you've got to count out 79 days from there. Okay, and there's ways you can do this, but you can see this is the 360th day of the year. So the way that I would do this is I would take 360 and we're going to add 79 to it. If we take 360 and add 79, that's going to be 439. And then we're going to subtract off one full year, 365 days. And I know you're like, you just said there's 360 days. No, I said if you're ever putting a number in a denominator, then you would put 360 in a denominator. There really are 365 days in a year, in a non-leap year. And so anyways, you subtract that off and you get 74. Now you would find the 74th day of the year. So you go back to this chart and you find the 74th day, that's right here. And that, of course, is March 15th. Okay, go back and review that if you need to. So a couple other problems. I already have the answers up, so you can kind of skip over these if you'd like. But if you want the due date of a loan that you take out on March 15th and it's a 120-day loan, all you would do is go to March 15th, which we were actually just there a second ago. That's day 74, right? And so you would take day 74, and then you would say, let's add 120 days to it. That takes me to 194. And then you would find the 194th day, which is July 13th. So that's how you can figure out things like that. Okay, let's get into it now. This is our last problem. It is a lengthy one, though. This is definitely the hardest problem of the day. Kathy's going to attend a conference, so she's going to take out a, wow, this is a long time ago. Someone needs to update their notes. Kathy takes out a 120-day loan for $400 at an interest rate of 12.5%. It's a little steep, but you know what? It's probably lower than a lot of credit cards. She uses some birthday money, so she's going to make a partial payment of $150 on January 5th. Then she makes a second partial payment of $100 on February 2nd. And ultimately, we want to know like how much is she going to pay back for her last payment? Because so far she's only paid back $250, and interest is going to be accruing this whole time. So let's jump right in. First, let's find the due date of the loan. Okay, well, here we go. November 1st is the 305th day of the year. She takes out a 120-day loan. That's 425. But wait a minute, you'd be like, there's not 425 days in a year. I know. So we've got to subtract off one full year. Subtract off 365 days so we can see what day that's going to match up with. We're not going to worry about leap years here. Okay. Plus 2006 wasn't a leap year. Neither was 2007. So we're good. All right. So the loan is due back on the 60th day of the year, which of course is March 1st of 2007. Okay. So we know the loan is due back on March 1st, 2007. Now let's figure out how much interest happens by January 5th. Now, why is that date important? It's because that's when she went in to make her first payment. She goes in on January 5th, and during that whole time, she had $400 out. So they are going to figure out, it's like she took out a loan for $400, well, she did take out a loan for $400, and we've got to figure out how many days she had that loan out so we can calculate the interest on just $400. So we're going to go from November 1st all the way to January 5th, and we would say that that's actually going to be So we would say, okay, well, 5 days gets us to, these 5 days. We also know that there were 65 days from, uh, sorry, there's 60 days to go from the 305th to the end of the year. So there's 60 days to get us to the end of the year. And then there's 5 more days on the front side of the year. So this is 65 days. She had the loan for 65 days before she made her first payment. Now she walks into the bank after 65 days and they're going to say, well, let's figure out your interest that you owe. That's what we want to know, is we want to know how much interest happened. You borrowed $400. You have a 12.5% interest rate, and it's been 65 days. Now remember, the banks always put 360 on bottom. Okay. So that means, Kathy, if that really is your name, that $9.03 worth of interest has accrued during this time. And so she's going to say, oh, okay, great, cool. Now remember how they, remember what they do with this is, according to the US rule, she's going to take this $150 that she's going to make a payment on, and they're going to say, oh, don't forget, according to the US rule, you have to pay $9.03 first. She goes, oh, okay, go ahead and take that out of this payment. So that means that $140.97 is what's credited towards the loan. That's what goes for paying down the money that she borrowed. Okay. So then we take the $400 minus the $140.97 gets us her new principal. Now this is one way to do it. I'm going to be honest, it's not the way that I typically do it. It's a nice way, and this is a great way of looking at it, especially for understanding buying a house and understanding just how interest works. It's really great to understand this. But there is maybe a little easier way to think about this, though, too. If she owes $400 and then she walks into the bank would say, you know what, $9.03 worth of interest has happened. So, Kathy, if you would like to walk out of here scot-free and like not have any more debt with us, you would owe us $409.03. And Kathy says, oh, cool, great. If I paid you all this, I'm off scot-free. And they say, yes. And she goes, okay, well, I don't actually have that. What I do have is $150. And they'd say, okay, cool, thanks for that. And so we'll go ahead and subtract that off. We get $259.03. Kathy, when you walk out of the bank today, this is how much money you still owe us. And she says, okay, great, cool. So she heads on out of the bank, and she comes back in on February 2nd. So January 5th was the 5th day. February 2nd is the 33rd day. And so that means then that 28 days later, it's a great horror movie about zombies. 28 days later, she comes back in to make a payment. We have to figure out how much interest happens during those 28 days. So we're going to do the same thing. Guess what? This gets really repetitive. We don't know. P, her principal for the last 28 days was $259.03. Not $400 anymore. We don't have to pay interest on the $400. We're only paying interest on the amount of money that she still owes the bank. She still owes them $259.03. Then her interest rate's still the same. Her time was 28 3/60ths. I equals PRT. We put all that into the calculator, and you find out that her interest is $2.52. Now, she's going to make a payment. Her payment is, I think she's paying $100 this time. And according to the US rule, you would take the $100 she wants to pay him. They subtract the interest off first, and they say, hey, you got to pay the interest. This is cool. $97.48 goes towards the loan, and therefore she now has a balance, a new balance. like shoes, of 161.55. Now, again, this is a nice way of doing things, and there's a lot of videos out there, and there's textbooks and everything that shows you that way, and it's really great for understanding, especially an amortization table for a house. That's not this lesson, though. What I like to do is I like to take the amount she owes, 259.03, plus the interest, because this is money owed. 252, that's also money she owes. And if we add that up, I figured out she owes them. The bank might say, hey, Kathy, it's February 2nd. If you want to walk out of here scot-free, not owe us anything, then you could pay us $261.55. And Kathy then would say, awesome, I don't have that much. She seems like the kind of person that would just be like, awesome. So we're going to pay $100. And the bank says, cool. You still owe us $161.55. And she'd be like, okay, neato. I'll be back when my loan is due. I'll be back when my loan is due so that I can pay that off. Okay, so her loan is due on March 1st. She says, I'll be back. I know right now it's February 2nd. I'll be back March 1st to pay off the loan. So guess what? This is repetitive, right? It's the same thing. It's the same problem over and over and over again. February 2nd is the 33rd day. March 1st is the 60th day. That's 27 days later. So 27 days later, she comes back in. They say, well, let's calculate how much interest you have. Interest we don't know. Your principal was only the $161.55. That's how much money you still owe to us. The rate was 12.5%. We always write that as a decimal. And then we would use 27/360. Remember, do not convert this to a decimal. Okay, let me just show you real quick. I mean, I just kind of bypassed it before. I assume everyone can put things in their calculator okay, but I shouldn't do that because sometimes people will make that into a decimal and they shouldn't. 0.125 times 27 divided by 360. You don't even have to put that in parentheses. You can. A lot of times I like to, but you can see this is 1.514 or $1.51. Now, typically, banks do have different rules on whether they round down or whether they always round up. Some banks actually have different rules about that, but for the most part, banks will just round appropriately to the nearest cent. And then it all kind of balances out in the end. All right, so she owes $1.51 in interest, and so that means that if she wants to pay everything off, she's going to take the $161 she still owes. She's going to take the $151 that she's paying in interest, and her final payment is going to be $163.06. Now, the question doesn't ask this, but I'm just going to think about it. How much was her total interest? Her total interest would be the sum of all of the interest amounts, right? Like we could take 151 plus she also paid $2.52, and she also paid the first month, I'm looking back through my notes here, $9.03. And you could add all of those up. 6, 0, 1, 2, 4, 13. $13.06 is her amount of interest. By the way, if you go through and figure out the simple interest for a $400 loan, for how long did she take this out for? I think it was 120 days. It's not $13.06. It's actually quite a bit more. Not quite a bit, right? But we're just doing a little extra here. I equals PRT. If she was not going to make any partial payments, if she was just going to take out $400, she was going to take it out at 12.5% for 120 days. I didn't work this out ahead of time, so we're doing it right now. So if she takes out a $400 loan times 12.5%, remember that's 0.125, times 123/60ths. Remember, because our interest rate is in years. Oh, looks like my time sign didn't go. Here we go. So 123/60ths. I didn't write that down a second ago. Then her total interest would be $16.67. Sorry for the sloppiness here. $16.67. Now, you might say, why is it that she paid different amounts of interest? Right? Why is it that she paid $16.67 if she did a simple interest, but if she makes payments, she pays less interest? Okay, well, it's because every time she makes a payment, her principal goes down. And so they're not charging her interest on the $400 for the whole 120 days. That's a simple interest formula. If she made no payments, she would pay this much interest. But because she goes into the bank and she tries to pay stuff off as she gets money, she says, hey, I want to get this, I want to pay this down, I want to pay this down, then she actually ends up paying less interest. Now, keep that as a lesson. If you can pay off your car a little bit earlier, if you can make extra payments, or if you can pay off your house a little bit earlier, you can make extra payments on things, then you'll end up paying less interest. Okay? All right, well, that's it for today. I know this is a long lesson. It's all about simple interest, and there's these problems can get really complicated for something called simple, right? But just do the best you can. Go back and rewatch the parts you need to, or I would really encourage you to explore a couple other websites. I'm a big promoter of Khan Academy. I think they do a great job there. They have a financial literacy class that you can go and study from. So good luck with everything. I hope this was helpful.